Hey everyone, welcome back to another video by Cam Room 5. In today's video, we're going to be talking about phenols and phenylamine. And we're going to see how phenols are good acids but phenylamine are bad bases, right? So when we look at the structure of phenol, we have the OH group, also known as the hydroxyl group. Here it acts as an acidic group. Why? This is actually because the OH bond within the hydroxyl functional group is weaker here. And since bond of O and H is weakened, it dissociates to release H plus ions. And that is exactly the definition of an acid, that is a compound that dissociates to release H plus ions. So that is why phenol acts as good acid, right? When we talk about phenylamine, actually the amine is a basic group. Now what actually happens is that the lone pair on nitrogen atom within the amine group is donated to a H plus ion. So this lone pair on the nitrogen atom is donated to H plus ions to accept them. And that is exactly the definition of a base, which means a compound that accepts hydrogen ions. This was important to discuss the definition of these compounds here, because it's going to be important to define them. Now the lone pair of oxygen atom and the lone pair of the nitrogen atom are actually involved in the delocalized system. So the lone pair of oxygen atom and lone pair of nitrogen atom are involved in the delocalized pi electron system. And when they're involved over here, they become a part of the resonance and there's a positive charge developed on both the atoms. So phenol is an acidic compound. Let's talk about why is it the case. Since the lone pair is involved in the delocalized pi electron system over here, that is exactly something that results in the dissociation of hydrogen ions. So hydrogen ions are released because obviously the O and H bond are weakened, easily breaks down. Another reason is that once the H is donated, the H ions are donated, the phenoxide ion is stabilized, because obviously the negative ion of the phenoxide is a pretty stable ion because the negative ion is spread on the entire benzene ring. So phenol dissociates in water and makes phenoxide ion, where there's a negative ion on the oxygen atom and hydrogen ion. Phenoxide ion is very stable because the negative ion is not just present on the oxygen atom, it is delocalized on the entire benzene ring. And that makes the equilibrium more towards the right side. When we look at phenylamine, what actually happens is that again the lone pairs are the main factor over here. So phenylamine is not a strong base. The reason is the lone pair of nitrogen atoms are involved in delocalized pi electron system. And when they're involved in this pi electron system, it is not available. By it I mean actually the lone pairs. So the lone pairs aren't available to accept hydrogen ions, and that is why phenylamine is not going to act as bases. So if you consider a molecule of phenylamine, for example this over here, and you make it accept a hydrogen ion, it would have made phenylammonium ion, where the NH3 gets a positive charge on top of it, but that is not a very feasible reaction, so it doesn't move forward, rather it stays backward. It moves in the reverse direction more. So this reaction is favored in the reverse direction, so phenylamine not a good base, phenol is a very good acid. The reason is same, that is the involvement of their lone pair electrons within the delocalized pi electron system. Phenoxide was stable, phenylammonium was unstable. Now let's have a bit about how we make phenol and phenylamine through the same series of reaction. First, you convert benzene into nitrobenzene using concentrated nitric acid and concentrated sulfuric acid as catalyst in the process known as nitration. You convert the nitrobenzene into phenylamine using concentrated HCl and tin metal, which helps in the reduction process, so the nitro group is reduced to imine group. Then you use sodium nitrite and HCl in the diluted state. Sodium nitrite is a highly reactive acid, so the temperature should be around 10 degrees Celsius. This reaction is known as diazotization, where you make benzene diazonium chloride. And finally, when the benzene diazonium chloride reacts further with the HCl upon warming, it makes phenol. So you can see this whole series of mechanism and reactions, and you should know what are the conditions. Reactions of phenol will include obviously the reactions where phenol acts as an acid. So imagine you have phenol over here, you are making it react with sodium, which is a pretty reactive metal. Your products are going to be a salt. So you get sodium phenoxide, where there is a phenoxide ion with negative charge and sodium is the positive charge. Hydrogen gas is released. Then when, in this case, basically phenol is obviously donating the hydrogen ions, and obviously the hydrogen ions are reduced later to make hydrogen gas. So the salt was named sodium phenoxide. Another reaction where phenol is also acting as an acid is the most common reaction of acids, that is neutralization, where you react it with sodium hydroxide, like basically an alkali, pun intended. You make again the same salt, which is sodium phenoxide, and in this case you make water. Again the same sodium phenoxide was made, so this is a general acid-base reaction. Lastly, let's talk about the coupling reaction of diazonium ion. When we talk about phenylamine, which has the capacity to make diazonium chloride, the diazonium ion has a positive charge on the nitrogen atom within the diazo group. And obviously, it is going to need electrons, which can be donated by any nucleophile. What actually happens is the pi bond between both the nitrogen atoms is broken, and benzene ring donates an electron pair to the positive nitrogen atom, because nitrogen positive atom was like an electrophile. This results in coupling reaction between both the compounds, and as a result, two benzene compounds are combined together. For us to have a clear picture of how this is happening, we should have a clear view of numbering. So I have numbered the left compound, the diazo compound, starting from the diazo group carbon, and this another one is also numbered starting from the alkyl group. So we can see the numbering also over here, which makes it clear for us how the complete reaction happens. So the fourth carbon from the alkyl benzene donated an electron pair to the diazo group to make a diazo-di. This is just a skill that you need to develop, and it is very rare that they will ask you in this examination, but you should know if such case happens, how you should answer that.